Okay, so I got an email today, a Canvas mail, thank you, that asked me for some help with the definitions of languages, strings, alphabets, and length. And I thought the easiest way to do this would be to make a very quick video. So the student is getting confused by the questions in the homework versus the definitions shown in the video versus the definitions in the book. And the student says, here's what I think the definitions are, and starts with a string and says a string is a sequence of 0 or more elements, asks about the notation, are braces necessary, other questions. So let me talk you through this in two ways. The first thing I'm going to say is that if you go into the week 2 module, yeah, here we go. There is a sheet. It used to be called Week 2 Extra Help Sheet Things to Memorize. I have just, hot off the presses, right before I made this video, decided to update it ever so slightly. But it has my definitions of what is an alphabet, what is a string, what's the empty string. And these are things that you should memorize this week. Memorize them this week and they will help you. This pink bit here is new because I think that will help you also. So alphabet is a finite set of symbols. So the student said sequence of 0 or more elements. Yeah, pretty close, right? Almost the way I would say it. Elements is a little bit less specific, but it's fine. 0 or more elements, yes. Okay, in terms of notation, let's just talk about this for 1 second. Maybe I will make some more space down here. Okay. Am I typing in purple? No, it's just because something is purple here. But it would be fun to type in purple, but it looks like I can't. But let's see if I can make it a little bit bigger. Here we go. Okay, so if you're doing strings in Java, right, we always write them like this with quotes around them, right? So we might write hello is a string, right? Or how space r space u is also a string, right? And that's one long string which has how many letters? 1, 2, 3, 4, because we count the space, right? 5, 6, 7, 8, 9, 10, 11. Okay. When we are working in foundations, we get very lazy very quickly. And so instead of writing hello with quotes, we're just going to write hello without quotes. And that's going to be our string, right? It's going to be this sort of sequence of 0 or more symbols. And we won't use the double quotes, but we kind of know they are there, right? Dealing with spaces is a little bit harder. I think what we're going to have to do, because if I showed you something like this in our class, hello, or if I showed you how space r space u in our class, because spaces mean something in English, they usually mean this is sort of a separator and we don't have the quotes anymore. I would say this is actually 3 distinct strings. And we would have to come up with some agreement like an underscore. We're going to use an underscore to represent a space for the purposes of our class. And so then we would say like how r underscore u. Now this is a single string and not 3 separate strings, right? And similarly, all of this is a bit arbitrary, right? Because we could, what makes a W, I don't like this autocomplete thing, but anyway, what makes a W a single symbol, right? What makes a smiley face a single symbol, right? I use that as an example in the lecture this week. And so it's because we agree to it, right? So we're going to agree that every letter of the English alphabet is just a symbol. And we'll agree that underscore is also a symbol. Now we have a couple of special symbols in our language that we are going to say these are sort of reserved key symbols like keywords in Java, right? We're never, ever going to use a curly brace to represent anything other than an open curly brace unless I explicitly say, you know what, think of this as a symbol right now and not as something to do with a set. Similarly, we're not going to use a closed curly brace for anything except sets. And another thing that we're going to use in this class is we're going to use commas, right? And a comma is something special. So we're never going to have, in Java, we could have a string that's like comma, 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 right? we're not going to have that string in foundations. We can always represent it if we really wanted to, but that just makes things more complicated. Okay, so if you ask me, you know, is this a string? Hello? Yep, that's a string. What about this? How are you? That's 3 different strings because for the purposes of our class, we're going to assume that spaces matter, right? If you want a set of 3 strings, now I've got how, comma, are, comma, you. Well, that's three strings in a set, right? And if we, let's see, so alphabet, finite set of symbols, right? A string is going to be one of these finite ordered sequence of 0 or more symbols. Ah, right. So in, where did my, here we go. In Java, we can put 2 sets of quotes together to mean the empty string, right? In foundations, we, you know, if we just left a blank, you know, with nothing, right? It's not even a blank. Ooh, that's cool. It's not even a blank that takes up 1 space. It's just nothing, right? We can't really write that. And so, you know, the lambda symbol here, it just means this space intentionally left blank. That's what we're doing, right? And as I said, language is a set of strings. So language absolutely has to be a set, right? Just like an alphabet has to be a set, right? So is it an alphabet? It better have set symbols on it. Is it a language? It better have set symbols on it, right? Now, up here I say an alphabet is a finite set of symbols. Down here I just say a set of strings, right, for our language. And so since I don't say it has to be finite, it could be infinite. Since I say it has to be a set, well, it could be empty, right? And up here I also say it just says a finite set of symbols, so an alphabet could be empty, right? And I guess now, do I have to update this form to version 3 now? This is actually probably version 50, but yeah, maybe I will upload again a variant of this that says, you know, may be empty, right? Because an alphabet can be empty. Now, the only other thing I'll tell you is lambda is never, ever, ever in an alphabet. It's special. I mean, if you thought about, again, thinking about the Java analogy, we have the letters on our keyboard, say, to use to make strings, right? Or anything that you can type on your keyboard. We don't have a specific thing that means the empty string on our keyboard, right? We just put nothing, right? So that lambda means I'm putting nothing here, okay? Now, what I thought might be helpful was if we went back to the class homepage and look at, it's going to make me watch the video. Let me stop being the student. Okay, if I scroll down to the old sample exams, and let's look at the sample practice midterm from fall 2020. And preview. Come on. Questions about sets and union. I know it's in here somewhere. And intersection. For the record, I had to make each of these questions a yes/no so that you wouldn't so that it could give you partial credit. Aha. Okay. So here's the question I wanted to look at. So let's look at this. So I have, it says let A, whatever the heck A is, equal this thing, and it says note absence of curly braces. All right. So A is this thing, and it says could A be an alphabet? So what I want you to do is look at your sheet that I have now hidden. If you go back to week 2 and you look at the memorize this, things to memorize, and yours is probably version 3 at this point. Okay, it says an alphabet is a finite set of symbols, right? So if we look at the sample midterm and it says, could A be an alphabet? Well, is this a set? No, because there's no curly braces. Done. Could A be an alphabet? No. All right. Then we ask, could A be a string? What's the definition of a string? Well, a string is a finite ordered sequence of 0 or more symbols. All right. So we look at this question, we say, well, it is kind of finite, but oh dear, it's got those commas in there. And we said that for the purposes of our class, ooh, it picked no for me. For the purposes of our class, these commas, we're not going to have them in strings. So this is not a single string. So could A be a string? No. All right, can I make this bigger? There we go. Is it making the font bigger? I can't quite tell. All right. Let's look at this one now, okay? So A is the same thing again. Could A be a language? Well, if we look at the definition of a language has to be a set of strings. Again, language has to be a set. And we say, is this a set? No, no curly braces, done. Not a language. All right. Let's try number B. B equals A, E, I, O, U. Note absence of curly braces. Could B be a string? Well, let's see. Is it a finite sequence of symbols? Yeah, it is. So yes, B could be a string. Could B be a language? Well, again, languages have to be sets, right? Is this a set? Do you see set symbols? Nope. No. Easy. Could B be an alphabet? Well, okay. So an alphabet has to be a set, so we know this is not. Even if there were set symbols around this, because we are going to agree in our class that that every symbol in the English alphabet counts as an individual symbol, this is not one mega symbol, right? And so, no, it's not an alphabet. For question B, let's just say no, because it's not a set. Done. Easy. All right. Here is C. Oh, look, we're finally got set symbols, okay? Could C be a string? Well, strings are not sets, right? What's a string? A string is just a finite order sequence of 0 or more symbols, right? Think of a Java string, right? It's not a set. Could C be a string? No. Could C be an alphabet? Well, let's look. C has one symbol here and then a comma. That would be fine. Another symbol and a comma, that's fine. So, look at this. Q and R squished together. That is a string in there. Did I say one string when I meant one symbol? Q is a single symbol. R is a single symbol. S is a single symbol. QR squished together, that is two symbols squished together. So can't be an alphabet because an alphabet is just a set of symbols. So no. Could it be a language? Well, a language is a set of strings, right? And each of these things separated by commas could be a string. So sure. All right. Last one, D equals the example that I wanted to look at. Good. It says, could this be a string? Well, a string is not a set for sure, so no. No. Could this be an alphabet? Well, an alphabet has to be a set of symbols, right? And this A, E, I, O, U thing squished together is one long string made up of 5 different symbols. So no, can't be an alphabet. Could it be a language? Absolutely. A language is a set of 0 or more strings, right? A language is a set of strings. I added the 0 or more to the help sheet because a set is, if I don't say it doesn't have, up here I said it has to be a finite set of symbols. I didn't say finite down here, therefore it could be infinite. I don't say it can't be empty, therefore it can be empty, right? But maybe I'll put that arrow up here too before you get to the sheet. Anyway, so what am I doing? So could D be a language? Well, a language is a set of strings. There is a set that has one string in it, so it is a set of strings. So I say yes, it's a language. So let's just go back to the questions in here, because there was also some measuring questions. So hopefully that cleared up the notation. Yeah, question 11 asks if just characters are strings, right? If you have a bracket on them, no, not a string, because brackets are special things in our class, and you can say that, you know, regular parentheses are also special if you want. We can and square brackets, we won't use those. And I think I got all of this stuff down, language. On question 12, it's asking what the following are. Now what's going on here is these absolute value symbols, the bars, get used. The reason I'm asking this question in question 12 is because the absolute value symbol bars get used for so many different things in this class, and you want to kind of get an idea of what's going on here. So, boy, this one I made hard because I made it's Rowan space rocks. I guess you just need to assume, this is a bad question. You need to assume that that space actually is a character here, and it's just asking how long is this string with that character in it. Right? On here, when I have the bars, because I have bars around a set, now it's asking you not how long is the string, but how many elements are in the set. So this would be 1, 2. And this is sort of a weird trick question. Maybe I should be getting rid of it, but notice that it's a set, but there are duplicates, right? So like this R-O, yeah, those are the only letters in both. So if you ask me how many things are in the set, right, and I didn't say it was a multi-set, and it was kind of bad, and this is sort of a yucky question, and maybe I shouldn't ask this question, but it's not going to make or break your homework, and it made you ask me a nice question so I could make a video, so good job. Anyway, so, you know, if we say, all right, that's how many things are really in the set, then we've got 1, 2, 3, 4, 5, 6, 7, 8, right? So I would say there's 8 things in here. And yeah, the answer is different for each of them, right? And yes, absolutely. I think that 1, 2, yes, and I would say 8 because it's set symbols. So if I undo here, that R is a duplicate and that O is a duplicate. But perhaps I'm overthinking things, but it's giving me great concern that I'm doing the entire assignment incorrectly. Yeah, thank you for asking this question. I hope this video was helpful. And I'm going to put it up on YouTube momentarily. All right. I just used the word momentarily the way that I don't think it should be used. Momentarily used to mean in a moment, or for a short moment, and now it means in a moment. But yeah, I will put it up. Anyway, hope you guys are enjoying the snow. Hope it doesn't snow too deep today. Talk to you later. Bye.